Ohm's law. Temperature and other physical conditions remaining constant, the potential difference between two ends of a conductor is directly proportional to flow of current through the conductor. To explain Ohm's law, we may compare the flow of current with flow of water. As water flows downward direction, likewise current flows from higher potential to lower potential. In the picture, tank A is placed at the higher position and tank B is kept at lower position. Both the tank are connected with a small pipe and a suitable tap. The tap will control the flow of water through the pipe. When the tap is closed, the water from tank A will not flow to tank B, and we all know it. The upper level of water at tank A is VA and at tank B is VB. At this situation, if tap is opened, then water from tank A will flow to tank B and the flow of water will be continued till the level of the water of both tank be same. The time taken to reach at the final stage, that is at equilibrium position, is totally depend on the control of rate of flow of water by the tap and difference of level of water at the tank. Similarly, we can compare the phenomena with voltage, current and resistance of an electrical circuit, where higher potential is VA and lower potential is VB. The difference of level of water at both ends is VA minus VB. Similarly, we can assume difference of potential at both ends of a resistance is VA minus VB. Water will not flow from A to B if tap is not opened. Comparing it with resistive circuit, current will not flow from VA to VB, that is from higher potential to lower potential, if the resistance is high enough, like insulator. When difference of water level is high enough and tap is opened in full, then rate of flow of water will be rapid. Like that, if a low resistance is used in that circuit, rate of flow of current will also be increased. Rate of flow of current would be minimized by using suitable resistance, as like flow of water would be minimized by controlling the opening area of the tap. Hence, resistance is acting as tap, flow of water as flow of current, and difference of water level as potential difference of an electrical circuit. Rate of flow of water will be also diminished if water level difference is decreased. Similarly, if potential difference VA minus VB is decreased, then flow of current through the circuit will be decreased. At this position, difference of water level is 0 and no flow of water will be occurred further. Likewise, if potential difference become nil, current will not flow through the circuit. So, flow of current is directly proportional to potential difference, as like rate of flow of water is directly proportional to water level difference, where R resistance is constant and opening area of the tap remains constant respectively. This is an electrical circuit comprises of a conductor having resistance R, potential VA at A end and potential VB at B end of that resistance maintained by a voltage source V. As per Ohm's law, potential difference between the two ends A and B is directly proportional to the flow of current through the resistance. That is, VA minus VB varies inversely as I. So VA minus VB is equal to Ri. R is a constant and resistance of the circuit. So R equal to VA minus VB by I equal to V by I. To flow current in any circuit, R resistance must be overcome by the driving force VA minus VB, the potential difference. Here V is measured in volt, I is measured in ampere, R is measured in ohm.